electric potential due to a point charge. Let us consider a point test charge Q0 is moved from point P to infinity, placed at r distance from the charge Q. In order to explain this, what I'm going to do, I'm going to draw a picture or a figure. So my figure is something like this, where this is my charge Q and point P is r distance from charge Q, where this test charge Q0 is located. And what we are doing, we are moving this point test charge from P to infinity. Then the electric field is given as, so basically what we are doing, we are trying to find the electric field at point P, and that would be E is equal to 1 over 4 pi epsilon 0 Q over r square. Since we are moving the test charge from point P to infinity, then the electric potential is given as Vf minus Vi, which is final electric potential minus initial electric potential, is equal to negative integration from r to infinity E dr. And the reason why we have a negative sign, because electric field will oppose any change. We know that the final electric potential is 0 and the initial electric potential is V. So let's substitute that value, and if we do that, we will write 0 minus V is equal to negative integration from r to infinity 1 over 4 pi epsilon 0 Q over r squared dr. Let's further simplify, and if we do that, we will write 0 minus negative V is negative V is equal to negative, I'm taking all the constant out, so dr and r square will stay inside and everything else will go outside the integral. So we'll write that is equal to negative Q over 4 pi epsilon 0 integration from r to infinity 1 over r square dr. And this negative will cancel out and we will get V is equal to Q over 4 pi epsilon 0 integration from r to infinity dr over r square. Now, in order to integrate this, what we are going to do, we are going to take this denominator to the numerator, and if we do that, we will write V is equal to Q over 4 pi epsilon 0 integration from r to infinity, and then this r square will go to the numerator and will become r to the power negative 2 dr. Now let's integrate, and if we do that, we will write V is equal to Q over 4 pi epsilon 0 r to the power negative 2 plus 1 over negative 2 plus 1, and a lower limit is r and our upper limit is infinity. If we simplify, we will get V is equal to Q over 4 pi epsilon 0 r to the power negative 1 over negative 1, lower limit is r and upper limit is infinity. Now let's simplify further, and if we do that, this r to the power negative 1 will go to the denominator and we will write V is equal to Q over 4 pi epsilon 0, and inside the bracket negative 1 over r, lower limit is r and the upper limit is infinity. Now let's substitute the upper limit and lower limit, and before we do that, we will take this negative to outside and then substitute the value, and if we do that, we will write V is equal to negative Q over 4 pi epsilon 0 inside the bracket 1 over infinity minus 1 over r, where infinity is our upper limit and r is our lower limit. And if we simplify further, 1 over infinity will be 0, and we'll write V is equal to negative Q over 4 pi epsilon 0, 0 minus 1 over r. Now, if we simplify further, then 0 minus 1 over r will be negative 1 over r, and we will write the expression over here as V is equal to negative Q over 4 pi epsilon 0, negative 1 over r. Now, let's multiply these two negatives and simplify further, and if we do that, we will get V is equal to 1 over 4 pi epsilon 0, Q over r. And this is the electric potential due to a point charge at a r distance from the charge Q. And this is how we will define the electric potential due to a point charge.